Okay, so now we're going to talk about density dependent and density independent factors. So we talked about human population growing exponentially, and then we talked about it slowing down. So what can cause organisms to slow down? So there are different factors. Factors that limit population size, there's density dependent factors. So if you have this deer, you put this deer in a park and you cram them up in a small space and they're going to poop. That's going to spread disease. It's going to destroy their food source maybe, and they're going to get poisoned from the poop. So that's the carrying capacity, limited space. So it has reached a limited space that might cause the population to slow down, population might crash. So that's density dependent factor. When you say density, that means the population becomes more dense. So density dependent factor is more of these deer you cram up together, a lower carrying capacity is going to be. So places like maybe New York, they're very dense, San Francisco, Paris, Hong Kong. So there's lots of people living in small places. So that's density. So when you look at the space. So when they're in the small space, and there's limited food, they start competing for the nutrients. They start pooping and they causes the environment to be really dirty. That's going to spread disease and that's going to cause the population to crash. And if you think about it, that's what happened with the coronavirus. People didn't want to be in smaller spaces. They had to be spread out for the disease to slow down, or they had to stay indoors. So being in a closed space can spread disease. That's a density dependent factor. So the effects of density dependent factors increase as the population density rises. Whereas the other, let me actually finish this. So most density dependent factors result from interactions between organisms. So this deer might be competing among each other for space, nutrients, food, and mates. And then the disease spreads easily if they're dense together in this space. And also there's risk of predation. So that also increases with the population density as the population becomes more dense. So that's a density dependent factor. Then we have density independent factors. Those are natural disasters, such as fire. So even if the population is sparse, they're spread out, there's not limited space, there's lots of space available. A forest fire can still come through. It's gonna come through regardless how the population, what the population size is. Hurricane can come through, a tsunami can come through, a flood can come through. Those are natural disasters. That has nothing to do with how dense the population is, how closely together they're living or how far apart they're living. So that's the density independent factor. So that's unrelated to population density, population size. Natural disasters like fire might eliminate half of the deer population, which is good because it's going to open up resources for the other weaker population, maybe, so the remaining population. So the natural disasters, they can be good because they can open up new resources for the population, and then maybe some of them survive. But this has nothing to do with the population density. So size of bacteria population in my hands is limited by frequent exposure to soap. Soap exposure is density dependent or independent. B, okay, yeah, that is correct. It is density independent. This is more like a natural.
Professor?
Yes.
I was just going to ask, could it also sometimes be density dependent if you literally see the dirt on your hands you go to wash?
Yeah, I was going to mention that if you can actually see the bacteria and then you go wash your hands and you only wash them when there's lots of them, then you would be looking at the density of the bacteria on your hands and then washing them. But if we're not doing that, because you can't really see the bacteria on there unless you have a microscope, then it's density independent. It's just like a flood to the bacteria or something like that. Okay, so human population has grown exponentially for last 2,000 years. So people like Elon Musk, they're looking for other planets to terraform other planets. So maybe people can go up there and live there. So maybe what they send 5 people up there and it takes a long time to spend billions of dollars. I guess they could use that money to reform the planet Earth here. We have the manpower, we have the resources. Maybe they can use that money to maybe help the Earth out. But when we're talking about the density dependent factors, it can be food, it can be space. So if you look around your room right now, you have lots of space. If you look out your window, there's lots of space. So space is not the issue. I think the resources are more of an issue for human population. So that's what's going to cause the human population to reach the carrying capacity. At the end of the lecture today, I'm going to tell you something about that's called ecological footprint. I don't know if you guys heard about that before. But that kind of looks into what you eat. Maybe you eat meat or you're vegetarian. Do you have an iPhone? Do you have a car? What do you require for living? So that's going to tell you what's your ecological footprint is. So we're going to look at that at the end of today. So human population has grown exponentially for the last 2,000 years. And again, it has a lot to do with science. Science finds a solution whenever there is a roadblock, whenever there is a disease that can take down human population, they come up with something. So that's why people should really be donating or should be supporting science programs that's educating people, that's coming up with new methods if they wanna support the human population, I guess. So let's look at the human population growth. So it has grown exponentially. Actually, I had this graph, I could have just looked at this. So it has grown exponentially for the last 2,000 years. But then again, the question is how large our population will be in 2050, 8 billion or 10 billion? Is it going to slow down? Maybe something else like coronavirus is going to come through and maybe, make our population smaller. So they have to look at different factors to look at the human population. Here, agriculture happened and then it started growing. Then there was plague here, dropped a little bit. Then industrial revolution. After industrial revolution, it just went up to the sky almost. So this picture here is showing you the human population growth, and it's showing you according to the countries. Less developed countries and then more developed countries. You would think that people would have less kids, I guess, in less developed countries, but it's the opposite. So you see the population this is the population, and then the colors are showing you less developed countries and more developed countries. People have less kids in more developed countries, and they have more kids in less developed countries. I want you guys to tell me some of the reasons for that, why that might be. Tell me in the chat. Cultural. Okay, so Justin's saying cultural. Education, more kids, more reproduction, knowledge of sepsis techniques, but lack of healthcare. So maybe no access to birth control. Okay, yeah, that's some of the reasons, but mainly, if you think about what people do in less developed countries, they are farmers, they do agriculture, and for agriculture to do labor, they're going to have more kids because they don't really have to pay them. That's one reason. Another thing is because of lack of the healthcare, not all of the kids survive to the age of reproduction. So they have lots of kids, and they have more kids because they can have them, do work, they can have them do farming, whatever they're doing, so they can kind of help them survive better in that type of environment. So this is less developed countries, and this is more developed countries. More developed countries, people are more educated, they have less kids, and in more developed countries, there's more jobs, and females, they mostly, go out to jobs. And in China, childcare is more expensive than, actually, you have to pay more into that than you're making from a job. So that might be the reason why people have less kids in more developed countries. These graphs are the age structure. So this is what we're going to look at next. Age structure. It's going to help us predict population growth. This is male. This is showing male, and this is showing female. And it's going to kind of look at individuals, looks at how many are there at what age, how many are there at their age of reproduction, how many are there as senior citizens, how many are there as young adults or babies. So that's what age structure looks at. So you have males and females, and this is showing India. India has growing age structure, like someone mentioned earlier. Now they have coronavirus, maybe it'll slow down, but they have a growing age structure, means they're growing in number. US, we have stable. We have the birth rate equaling the death rate. Then do you guys see this bump here? Do you guys know what that is? It's a term in pop culture.
Baby boom.
Baby boomers. Those are baby boomers. So after World War II, when guys came back, they had lots of kids. So that's why you have this big bump here. And then China, countries like China, they're declining. So their age structure, their population is basically, they're not reproducing, they're not having kids, declining. Now, you can also look at the age here. You have this many babies from 0 to 4, 15 to 19, maybe 75 to 79. So if all these kids survived, then they have to come up with the infrastructure to make sure that all the kids that have survived and they become adults and get older, they have the ability as a country to support that old age. Because otherwise they're going to get lots of senior citizens who cannot work anymore, and it's not going to be good. So they have to maybe come up with something where there is something to support all these individuals that are young now, and when they get old, they have to have some type of plan to support that. For the United States, a stable population, so there's nothing that needs to be done. So infrastructure doesn't need to be changed. The birth rate equals the death rate, so stable. Just a good infrastructure for older people. Because the number of older people dying is equaling the number of people being born. It's going to be flat. And then we have countries like China, Japan, and Italy. So it's upside down structure. They are not having kids anymore. Can you guys tell me some of the reasons they might not be having kids?
Overpopulation.
What did you say?
Overpopulation.
Overpopulation? No, their government's actually giving incentives for two couples to have, as many kids as possible. So if we talk about Italy, they have lots of money. Italy have a lot of money, so that's not an issue. But some other things. So if I ask you guys, how many of you guys are planning to have a kid this year? So let me in the chat. Anyone are planning to have a kid this year? Maybe one person? No? Nobody? Okay. So out of maybe we have 28 people right now, maybe one person said they might have a kid this year. So if you really think about it, nowadays you have the college requires a lot of money. You spend a lot of time in college, then you have to look for a job. Once you have a job, you want to have a house and you want to have a stable life before you get married. Then you get married, then you have a kid. And by that age, it's in Italy and Japan and countries like that, the people, they already passed the age of fertility, age of reproduction, then they're going to have lots of fertility issues. So that's one of the reasons, because they spend so much into education, time into getting education, maybe having a stable life. They kind of pass the age of reproduction, and then they have fertility issues. So people there, the government there is giving them money if they have maybe certain number of kids. They're trying to kind of bribe them into, because their population is declining. So that might be the reason, some of the reasons.